Hey there! If you're given with this item to evaluate the Laplace transform of the cube of t plus 1, don't worry immediately. Because you might think here that if you have here the cube of a binomial expression, so you're going to use the same expression for the Laplace transform of any function of t, equivalent to the integral from 0 to infinity of e to the power of negative st in your function of t dt here. And you might think it's actually like this, e to the power of negative st, and you will have here the cube of t plus 1 dt. Well, you can use that, and of course, when you think about this one here, you have a exponentiation of a certain algebraic expression. So you can actually work on that if you would like to, but definitely it will not hurt us if you're going to express the cube of t plus 1 into an algebraic form, so that our form later on for the Laplace transform is easier. Take note that the cube of t plus 1 is equivalent to t cubed plus 3 t squared plus t, and then you have here, plus 3t, plus 3t, and you have here plus 1. This will then be used instead of the cube of t plus 1 in our Laplace transform. And we know that there are rules already for 1, for t, t squared, and t cubed, and therefore this is actually just an easier problem. So the Laplace transform of your t, the cube of t plus 1, is equivalent to the Laplace transform of your t cubed plus a 3t squared plus a 3t plus 1, which is equivalent, according to the linearity property of Laplace transform, we have here the Laplace transform of t cubed plus the Laplace transform of 3t squared plus the it's not parentheses, by the way, it should be in braces. So allow me to do that. Laplace transform of 3t plus the Laplace transform of just 1. And at the same time, again, according to linearity property, we can take out these constants and make it as a scalar later on. So it would be equivalent to this, the Laplace transform of t cubed plus 3 times the Laplace transform of t squared plus 3 times the Laplace, that should be the Laplace transform of your t, and you have here plus the Laplace transform of simply 1. If it's actually 10 or 20 or negative 5, factor them out to get the Laplace transform of 1. This is because you already have the rules for those. The Laplace transform of your t cubed is actually equivalent to 6 over s to the power of 4. Okay, that's the equivalent for the Laplace transform of our t cubed. As for the Laplace transform of our, let's say, t squared, it's actually equivalent to 2 over s cubed. The Laplace transform of our t is equivalent to 1 over s squared, and the Laplace transform of a constant 1 is 1 over s. So by using all of this here, so this is actually equivalent to 6 over s to the power of 4 plus a 3 times 2 over s cubed plus a 3 times 1 over s squared plus 1 over s. So the result for this is actually 6 over s to the power of 4 plus 6 over s cubed plus a 3 over s squared plus 1 over s. This is equivalent to the Laplace transform of the original function, the cube of t plus 1. So see, just by getting the value of that, not doing this, which would take us a lot of time, other considerations, integration by parts, and other rules for integration. So we expand it in this form, so we're able to use the linearity property to get this result. So this is the result for the intended item. And again, try to review all of this if these are actually correct. And this is now the result for this video. Thank you very much for watching.